Hello guys, so we'll be continuing the series with respect to stats. In this video, we are going to discuss about t-stats and t-test. Okay, and already we have seen in our previous video about z-test, how did we calculate it, what formulas we used. Understand the point, the difference between z-test and t-test is that whenever you have a population standard deviation and when your n value is greater than or equal to 30, please try to use z-test. We have to use z-test. I'll not say please, but we have to use z-test to do any kind of analysis. But let's say if your population standard deviation is not given, then at that point of time, you can use t-test. So let's quickly go ahead and let's try to understand with this particular question. And this question, in this t-test, there is a problem which is called as one sample t-test. We'll try to solve this, okay? And by this, you'll be able to get an idea like how you can solve or how you can do analysis using the t-test. So in the population, the average IQ is 100. A team of researchers wants to test a new medication to see if it has a positive or a negative effect on intelligence or no effect at all. So initially the average IQ is 100. Okay. So a team of researchers wants to try a new medication and give it to the people to see whether there is an effect on their intelligence, whether it is increasing or decreasing. See, whenever I say increasing or decreasing, this becomes a two-tailed test. Okay. Always remember that. A sample of 30 participants who have taken the medication has a mean of 140. See, initially 100 it was. And when we took a sample, it is nothing but 140 with a standard deviation of 20. Did the medication affect the intelligence? So this is what we really need to check. Okay. And over here, we are going to initialize our alpha value, or I can also say my confidence interval value to 95%. When I say 95%, my alpha is nothing but 0.05. Okay. Now let's try to solve this problem and let's see what all information we can basically take out from it and what kind of analysis we can do. But in short, we are probably doing an analysis on this sample data to probably conclude whether the intelligence has increased or not. Okay. So let's start this problem statement. So first thing first, first step is always to write all the parameters that you have. Mu is equal to 100. So you can see the average IQ. See over here, population standard deviation is not given, right? If population standard deviation is not given, you have to use t-test. A team of researchers wants to test a new medication, blah, 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 blah. A sample of 30 participants is there. So n is equal to 30. X bar is nothing but 140 and small s sample standard deviation is nothing but 20, right? So has a mean of 140 with a standard deviation of 20. Okay. And we know our CI confidence interval is 95% and my alpha value is 0.05. So all this information is there. So the first step is with respect to what is your null hypothesis. Okay. Very simple. So first step is basically talking about your null hypothesis. What is your null hypothesis over here? It will be H0. You can definitely see what is the basic assumption in this question. In the population average IQ is 100. So can I consider my null hypothesis to be mean is equal to 100, right? Now, similarly, when I go with respect to the alternate hypothesis, this is nothing but H1. And over here, my mean will not be equal to 100 because over here, a team of researchers wants to test a medication to see if it has a positive or negative effect on intelligence or no effect at all. So either like from this analysis that we are going to do, probably we are going to get the average IQ more than 100, less than 100. So this becomes a two-tailed test. Two-tailed test. Okay. Now coming to the next one, very important step. Here you know your significance level, that is alpha 0.05, right? Now, whenever you are given a t-test problem, I need to compute the degree of freedom, right? We have also discussed in student t-distribution. Over there, with the help of this only, we will be able to see from the t-table, right? What is the area under the curve, right? So in this scenario, my degree of freedom is nothing but n minus 1, which is nothing but 30 minus 1, which is nothing but 29. Okay. Now coming to the major step, which is called as decision rule. What decision rule we need to select based on the visualization diagram, right? So usually in this scenario, I will be getting a curve like this. Okay. Let's say this is the curve. You know, you want 95% confidence interval. So this area will be having 2.5%. This area will be having 2.5%. Now we really need to find out the Z score by using T table, right? And how much it is away from the mean, that we will try to find it out. Okay. Now in order to find it out, we will use degree of freedom. We know what is my alpha. We know it is a two-tailed test. Now all I'll be doing over here quickly, I will go back to my T table. right? So in this T table, you will be able to see that on the top here you have one tail, two tail. We know that it is two tail. My alpha value is 0.05. Now on this axis you see degree of freedom. My degree of freedom is 29. So if I probably go and select this last one, last data is basically talking with respect to, not last, sorry, this one, 0.05 and 29. So I will be getting somewhere around 2.05, right? So this is basically my Z-score value. In short, when I say Z-score, how many standard deviation is away from the mean, right? That specific value, that 2.5 percentage which is present in the extreme end. So finally, I'll be able to see that it is having 2.045. So again, how did I do it? Degree of freedom 29. With respect to this, I'm seeing over here, and I'm probably checking out this, which is my alpha value. Okay. So again, repeating 2.0545, right? So I will go back over here. This will be my plus 2.045. And since this is symmetrical, I will be having minus 2.045, right? Now, when these values are there, now what is the assumption that we are going to make over here based on this decision rule? Very important assumption, right? The assumption is very much simple, guys. In this case, we will try to calculate the t-test, right? We will try to calculate the t-test, and based on the t-test, we need to really assume with respect to this decision boundary. So if my t-test is less than minus 2.045, that is in this region, or greater than 2.045, that is this region, right? Then what do? We reject the null hypothesis. In the last example, we did Z-test when a population standard deviation is given. Now we will try to find out what is this t-test. Okay, so this is my decision rule. Okay, now let's go ahead and compute it. So my next step is calculating the test statistic. Okay, so here you have t formula. You know that we have discussed sample standard deviation by root n. So we have all the values. X bar is nothing but 140 minus 100. Sample standard deviation is 20 divided by root 30. So if I probably go ahead and calculate it, I have already done this calculation. You can try. I am going to get somewhere around 10.96. Now this is my t-test value, the t-test value. So t is equal to 10.96. Now you know that this t, whether it is greater than 2.05 or less than 2.05, it is obviously greater than this. It is obviously in this scenario, right? It is obviously greater than this. So it may be falling in this specific region, right? So here I can write, since my t-test value or my t value, since t is equal to 10.96 is greater than how much is the value? Is greater than 2.045, right? 2.045. It falls in the extreme end, the rejection area, right? This area is basically a rejection area. You know this, right? It is a rejection area. This area is also a rejection area. And this area is basically my this area that you will be able to see over here. This area is my approved area. So basically my null hypothesis is true in this case, right? So I want to probably come in this particular area, but right now I am getting somewhere around 10.96, which is greater than 2.045. So we have to reject the null hypothesis, right? So at the end of the day, what analysis we are able to make from here? That whatever medication has been used, that has affected the intelligence. So final conclusion is that medication used has affected the intelligence. Now since my t-test value is a positive value, which is at this end, and this median was basically my intelligence, right? 100 IQ, right? And we are getting somewhere over here. So definitely it shows this medication has increased the intelligence, right? So specifically, if you really want to know over here, the medication I can also write has increased the intelligence, and this is the conclusion we make out of this particular statement or this particular problem, right? So I hope you are able to understand about t-test. This problem statement is also called as one sample t-test, right? Further going ahead, we are also going to see examples with respect to chi-square, ANOVA, f-test and all. So yes, but I hope you got an overall idea with respect to this. You can definitely try with different problems. You can try with different confidence interval like 99% and all. That is up to you. But at the end of the day, you are doing some analysis, you are doing some kind of conclusions, right? So yes, this was it from my side. I will see you all in the next video.